Hi, so on a previous video on making tongue drums, we calculated the length of the material we needed, and of course it was based on this thing, a guitar. And if I take one of those strings and pluck it, we get a note. Now the string is the same string, so if I shorten that string by fretting it, what I'm doing is changing the vibration length, because the string vibrates two fixed points. And if I shorten the string, we get a higher note. Keep on shortening, the note goes higher and higher. So there's a clear relationship between length and frequency. And this is something we all know, and it's something we experience readily with a guitar. But there's something else going on with a guitar. This string here is actually very fine. This string here is much thicker. And you can hear that the note is much deeper. Now, the tension on the strings, assuming they're the same, don't really account for it. What accounts for it is the mass on the string. So the mass of the vibrating material also has an impact on the note that you're going to sound when you vibrate that material. Now this is a string obviously, and it's vibrating between two fixed points, which is here and here. And we're changing the fixed point to one of the fixed points of vibration by shortening it, by fretting it. But we can have one fixed point, which is what reed instruments and tongue drums and lots and lots of instruments are all about. They have a single point. When they have a single point, they vibrate like that. When they have two fixed points, they vibrate like that. Now, it's a bit more complicated than that for the purists, but it will do. And in a tongue drum, we're using a one fixed point. In a guitar, we're using two fixed points. But it doesn't matter. The string changes note as a consequence of the mass of material that's vibrating. Now we can use that information. So what I've got here is a block of wood. I mean, it's actually two floorboards, in fact, because I do have quite a lot of this stuff that I found, which is oak flooring. I put two together, and all I've done is cut the slats out. You can see there are 8 slats, and I've created different length slats in line with what we were talking about when we were talking about the last video. However, those slat sizes have in fact just been random. I've just chosen them. And there's something else about this that I want to show you. So I've got a couple of bits of wood in my vise, and they're in fact just bed slats actually, so it's a cheap pine that I've put in there. And they're gripped in here because we need a firm fixed point. So they're like a reed, they're just sticking up there, gripped only in the vise. And if I hit that one, we get a note out of it. Now, let's say a note. I mean, I know it's a bit more of a noise, but it's actually a note. If I hit this one, which is exactly the same length, can you hear the difference? There's a difference in the note, but there's also a difference in the quality of it. This one has a router cut in the bottom there, halfway through the material. What you should have heard is a more ringing quality to the sound. So this one has a much more pleasant sound than this one, even though the mass of the material has changed only very slightly by that router cut. So what's happening is it's more free to vibrate at that point than it is here. This is a much stiffer material. This is a much more flexible material at that point, and so it's more free to vibrate even though it's vibrating a mass. So the tone changes, yes, for the reduction of material, but the freedom to vibrate improves the quality of the tone, and you get much more of a ringing sound. Isn't that interesting? So I've incorporated that into my floorboards. So I've marked the floorboards out, I've cut them out there, and then halfway along I've drawn a line 2 centimetres up, cut it, and then reduced that line by 1 centimetre. So each of those is randomly a different size. However, I've also put a router cut right there where those drill holes are to improve the tone and quality of it. We used that idea to make this aluminium harp in the previous one, where all we've done is change the length of the material. Now put it in the vise for its fixed point. If I hit that, almost a bell-like chime, a lovely ringing sound. Isn't that cool? So this length of material, plus the vibrating mass, plus the reduction to give you much more of a ring and a gentle tone is what went into this. Now this hasn't been tuned. The length is pretty much what I guessed at, really. It really is just a choice of midway plus a bit, nothing else. That was added to give you a more pleasant sound, and if we put that in, you should be able to hear it's got much more of a mellow tone. So these principles really, I think, are what need to guide you in making something like a tongue drum. Now we tune that by removing massive material either at the tip or at the base. And if we remove the mass of the material, then we'll be able to get these in tune. The length of them makes them relatively tuned to each other, not obviously tuned to an orchestra, but relatively tuned to each other. And removing massive material is how you bring it into tune all by itself. Now I chose that centimetre because if we look at the aluminium harp, the differences in the different notes actually is not great. So you're only talking about a centimetre or so. Now these things obviously have restrictions on them because of the size. There are some notes we're not going to be able to reach however much material we remove. And of course the size of it means that the lowest note is going to be fixed. So there are limitations in the actual size of it, but you can be guided in the design of this by general principles rather than complex calculation. So the things we can learn from a guitar to take to making drums are that there's a change in length of the material, a change in mass of the material, a firm fixed point to hold the material so it can resonate, and then obviously a sound chamber. I mean, this is an electric guitar, but a normal guitar obviously has a hollow body with a hole in it where the sound can resonate, like a violin. Now we're missing the resonant chamber, which is why the sound was actually quite low, but if you look on how to make tongue drums, you'll see them just making all kinds of resonant chambers, where the best you make an airtight box and put this on. The airtight box and putting this on is always, it's no real challenge, make a box. The challenge really has been how do you design the tongues? And it really comes out to, it doesn't matter. Really, put any design you want on there, which is why you see so many curvy designs. I personally don't like those curvy designs. I'm a rigid guy, I like straight lines. But you can pretty much put anything you want on there. And that's why there is no real guidance to it, because none is needed. You can put what you want on there. You need to stick to the principle of firm fixed point. Really helps to put this cut in so it resonates much more better. You get a much more mellow tone. And then after that, vary the size a little bit because it makes tuning it easier. But you tune it by removing massive material at the tip or the base. Anyway, that's actually all you really need to be able to make your own tongue drum. No complex calculations. Draw what you like. Get yourself a tuner and off you go. So I hope it was of interest, and thank you very much for watching.